Why is understanding climate change important? Global climate variation has profoundly influenced humans throughout history. Animal and flora populations have also been greatly impacted by a changing climate. Until recently, however, a change in the climate has been brought about by natural causes, such as variable solar output, slight changes in Earth's orbit, and major natural disasters such as meteoric impacts. Some of these changes in climate have occurred when the human population was much smaller than it is today, and societies were much less dependent on complex and interrelated technical systems. We now find ourselves in a situation where human activities are exerting noticeable effects on the climate, and climate change is taking place on shorter timescales than in the past. The important point to keep in mind is not that the climate is changing, but the rate of change is much faster than in the past. And, as I mentioned, when the population was much smaller and less dependent on complex, interrelated systems such as electric power grids, oil and gas infrastructure, global transportation, and global electronic connectivity. In addition, we now know that human activities themselves are an important cause of the observed climate changes. This means that any response to climate change will be exceedingly difficult, as it not only requires utilization of a broader range of energy resources than the traditional carbon-based fuels, but also different behavioral patterns for many people. I'll now discuss some of the basic facts about climate change. By climate change, we mean a change in the state of the climate that persists for an extended period, decades or longer. Global warming is just one manifestation of climate change. Climate is not the same as weather, although they are related. Climate is the long-term average of weather. We all know that climate changes over time, and depending on the time scale, that change can be small or large. For our purposes, however, the most significant change in the climate has been the relatively rapid increase in Earth's average global temperature, or global warming. Some of the consequences of global warming have been a rise in sea level, rapid melting of glaciers, decreased sea ice coverage, increasing temperatures of the oceans, and more extreme weather events. The spread of certain disease vectors can also be related to an increase in the average temperature of the Earth. There are other manifestations of one of the root causes of climate change, that is, increasing carbon dioxide levels in the atmosphere, such as increasing acidity of the oceans. The increase in acidity, as well as ocean warming, has profound effects on mollusks and coral reefs, for example. When discussing climate change, it is useful to separate out what are the causes that bring about a change in the climate, the changes that take place, and the effect of these changes on humans, fauna, and flora. The root cause of global warming and related climate change is the buildup of heat-trapping gases in the Earth's atmosphere, the so-called greenhouse gases, or GHGs. The presence of these gases, the most prominent being carbon dioxide and methane, trap heat radiated out from the Earth, causing the temperature of the Earth to be much warmer than it otherwise would be if these gases were not present. This is known as the greenhouse effect. We won't be going into the physics and chemistry of this phenomenon, which is well understood and documented, as we are mostly interested here on the effects of climate change and global warming are resource management and productivity. Now, how do we know that global warming is real? One way to determine this is to look for climate change indicators. So, for example, if the Earth is warming as expected from increased carbon dioxide emissions, what would one expect to see, for example, in the level of sea rise? Some of the most important indicators of climate change are globally averaged air temperature, sea surface and land surface temperature, ocean heat content, sea level, snow cover, and the extent of glaciers. In each case, one would expect either an increase or decrease as a function of climate change. For example, air and sea surface temperatures, sea level would be expected to rise, whereas glacial extent or snow cover would be expected to fall. What one finds when measurements are taken around the globe, usually over a long period of time and consisting of thousands or tens of thousands of data points, is just what is expected from increasing levels of greenhouse gases in the atmosphere. Keep in mind, what is measured and what is expected does not depend on any models of the climate. We know from direct measurement that global warming is real. But we also need to establish what is causing the planet to warm at a rapid rate relative to previous changes in the climate. This is more difficult to establish than the observed fact of climate warming. To determine the causes of climate change, scientists try to identify all the known causes and then assign how much warming one would expect from each cause. This has been done over many decades, and the overwhelming consensus among geoscientists is that a significant fraction of the warming in the last 100 years or so is due to human activity, especially the burning of the carbon-based fuels, coal, oil, and gas, which release carbon dioxide into the atmosphere. Thus, the conundrum. The combustion of fossil fuels formed and still forms the foundation of all we call modern industrial civilization, and is the basis of the wealth of all industrial and so-called post-industrial societies. At the same time, however, these very fuels may bring about ecological damage on a global scale that make continued progress impossible and cause great harm and damage to the very foundations that support human, animal, and planet life on the planet. The great challenge posed by rapid global change and associated warming is how to provide the energy resources for the current 7.2 billion people on Earth, expected to grow to 9 billion in 30 years, in such a way that does not destroy the basic environmental, ecological, and societal infrastructure that all life depends on. So what might we expect in the future? Niels Bohr, the famous Danish physicist, once said that prediction is very difficult, especially when it is about the future. If prediction is difficult in physics, it is much more so when it comes to earth sciences in general and climate in particular. In trying to get a handle on how the climate might evolve in the future, scientists utilize computer models based on known laws of atmospheric science and think in terms of a range of possible outcomes or projections rather than specific predictions. This is because the climate system is so immensely complicated and encompasses not only the laws of physics and chemistry, but also biology, economics, chaos theory, geology, oceanography, and complex feedback mechanisms. However, despite these complexities, climate models have made great progress in recent years, and thanks to advances in computing power, have provided a guide to what the future climate might look like within a range of possibilities. The United Nations Intergovernmental Panel on Climate Change, the IPCC, is the official entity that produces a comprehensive report every 5 years about the state of the planet and the latest projections. The reports, called assessment reports or ARs, are consensus documents based on extensive review of all the studies and literature related to climate change. The latest full report, called AR5 in 2014, provides future projections for relevant climate parameters based on different input scenarios. Graphic 1 illustrates the projected range of future temperatures for different input scenarios. You can see a wide range of values with greater uncertainty as one goes further out in the future. The different input scenarios are labeled RCP, standing for Representative Concentration Pathways, a cumbersome and not illuminating description. The point to keep in mind is that the higher the RCP, the more intensive is the use of fossil fuels, and the greater the amount of carbon dioxide emitted to the atmosphere. Not surprisingly, the higher the RCP values result in higher temperature increases over the course of this century. So how does one interpret this information, especially from a business perspective? I tend to look at the not too distant future, say the 2030 to 2050 time period. As the closer to the present, the more accurate are the projections. This time period is only 13 to 33 years in the future, and for planning purposes, especially large infrastructure projects, this is not an unreasonable time frame. We see that by 2050, there is likely to be an increase in the average global temperature anywhere in the range of 0.8 degrees Celsius to 1.8 degrees Celsius. My guess is that it will be even higher because there seems to be no real concerted effort to reduce our reliance on fossil fuels, which today account for over 80% of global energy use. Keep in mind that a 1 degree global change is significant because it takes a vast amount of heat to warm all the oceans, the atmosphere, and land by that much. In the past, a 1 to 2 degree drop in temperature was all it took to plunge the Earth into the Little Ice Age. A 5 degree drop was enough to bury a large part of North America under a towering mass of ice 20,000 years ago. I'll now focus in a little more detail on the energy sector because it is the main contributor of greenhouse gas emissions to the atmosphere. Currently, about 80% of global energy use is derived from the three main carbon-based fossil fuels: coal, oil, and natural gas. Although renewable energy use is growing, projections to the year 2040 show that fossil fuels will still dominate global energy use, accounting for about 80%. In addition to fossil fuels providing the bulk of energy use to 2040, the amount of energy consumption will also increase significantly, about 48% from the year 2012 to 2040, according to the United States Energy Information Agency. Thus, by close to mid-century, more fossil fuels will be used to meet energy demands than are used today. These projections were prepared before the current administration came to office in the United States in 2017, And given the policies of this administration, one can reasonably expect that fossil fuel use will increase even more rapidly than the projections indicate. Such a situation, currently and projected to the near future, obviously will have a deleterious effect on the climate and global warming. The situation is not entirely bleak, as renewables and energy efficiency are expected to benefit from new technologies and government policies, at least in countries other than the US. Also, it is expected that natural gas will replace coal as the main fuel for power generation. Although natural gas still produces carbon dioxide when combusted, and methane, which is the principal component of natural gas, is a potent greenhouse gas if released to the atmosphere, overall, the use of natural gas as a fuel is less deleterious than the use of coal. The Paris Agreement, which came into force in November of 2016, aims to lower average global temperature increase to 2 degrees Celsius by the year 2100. To achieve this would require a major change in the energy sector. Even if all the countries of the world met their pledges to reduce greenhouse gas emissions, this would result in an increase of 2.7 degrees Celsius by 2100. To achieve even this goal, the world's energy system would have to be based on carbon-free fuels by 2100, a very unlikely scenario in my view. The number of electric cars, for example, would need to exceed 700 million by 2040, also a very unlikely scenario. To make this a little more concrete, the graphic shows you what the energy sector would look like if all nations met their Paris Agreement pledges. Also included is a graph showing the energy sector CO2 emissions to achieve a 2 degrees Celsius scenario. So what does all this mean for businesses that are trying to develop innovative strategies to compete in the 21st century? It is in the arenas of trying to mitigate the causes of climate change and of adapting to its likely effects that one finds many opportunities for businesses. These opportunities could be in inventing new technologies, developing innovative strategies, creating educational products and services, and providing advice to local, regional, and international bodies responsible for implementing climate-related policies. Mitigation would involve developing new technologies and strategies to reduce the emissions of greenhouse gases into the atmosphere, continuing the improvement of renewable energy technologies such as wind and solar, creating viable methods of carbon capture and storage, developing new materials and strategies for energy conservation and efficiency, analyzing recycling of materials to reduce energy use, and developing materials and manufacturing processes for enhanced battery storage. In the energy sector per se, opportunities exist in the solar, wind, and most importantly, energy storage. Global wind installed capacity in 2016 was 54 gigawatts, making the total global capacity nearly 487 gigawatts. This is still only 8% of global electricity capacity. However, in some countries, wind is growing rapidly and is accounting for an increasing fraction of power production. Solar thermal and photovoltaics still count for a very small portion of global capacity, but advances in materials and power systems have made solar price competitive in some regions, especially where conventional fuels are expensive and climate conditions are appropriate. Where many opportunities exist are in the area of energy storage. Because the sun and wind are intermittent, the ability to store and then recapture stored energy can put intermittent energy sources on a par with baseload power, making these renewable resources much more valuable and dependable. Energy storage has become a major industry, but there is still room for small, innovative companies. It is projected that by 2022, energy storage will grow to 40 gigawatts, up from 6 gigawatts projected for 2017. There are many ways to store energy, such as large dams, big magnets, and large capacitors. However, the most likely technology will be batteries. In 2014, 70% of all electricity storage used lithium-ion batteries. One controversial field now under study is called geoengineering. Geoengineering uses technologies to try to remove CO2 from the atmosphere or to block sunlight from reaching the Earth. Some examples are iron fertilization of the oceans to increase biological activity, which in turn is supposed to increase carbon dioxide uptake in the oceans, or blocking sunlight from reaching the Earth by placing reflectors in the upper atmosphere, or by introducing aerosols into the atmosphere. Geoengineering is very controversial, mostly because one is experimenting with the whole Earth, and unforeseen consequences could result that could affect huge numbers of people. However, given the fondness of technological solutions to many problems humans face, I suspect that ideas for geoengineering will continue to evolve. In the area of adaptation to the impacts of climate change, sea level rise, spread of disease vectors, altered precipitation patterns, and extreme weather events are areas that all need new and innovative products and strategies. For example, the effects of sea level rise will impact millions of people living in coastal zones all over the world. For some small, low-lying island nations, sea level rise threatens their very existence. What new technologies are available to hold back the sea? How much will they cost? Who will invent them? And how will they be deployed? These are all questions and areas that businesses and governments will need to face, and innovative and creative solutions will need to be developed. Now that we've discussed the basic realities of climate change, some of the projections for the future effects of global warming, and what may be approaches to mitigate and adapt to changes in the climate, I'd like to offer some of my own thoughts on the subject. There is no doubt in my mind that the average temperature of the Earth has warmed during the last 100 years, at a rate not seen during any time during the last million years. The main cause of this warming is the rapid increase in the concentration of carbon dioxide due to the large-scale use of fossil fuels, beginning with the Industrial Revolution in the mid-19th century. Since it is likely that fossil fuels will continue to be the principal source of energy for at least another 50 years or longer, we can expect further warming of the planet, perhaps over the course of this century. This warming could exceed 3 to 4 degrees Celsius, with very serious consequences. These consequences will be seen in sea level rise, which in turn will impact coastal regions, more extreme weather events, shifting agricultural patterns, change patterns of water use, and exposure to disease pathogens in regions previously free from these pathogens. There is also the very real possibility of conflicts arising from water shortages and increased competition for agricultural land. In fact, the U.S. military has identified climate change as a serious concern for future conflicts. Despite these grave consequences of increased global warming, there are also opportunities. The most promising are in the area of new technologies related to energy, not based on carbon fuels and carbon storage. I can envision a world where the energy system will be almost carbon-free by the end of this century. We could see major gains made in using energy more efficiently in the transportation sector and the use of electricity. Although a great deal of money is being spent on nuclear fusion as a future energy source, I remain skeptical that the required materials and confinement technologies will be developed over the course of this century. Finally, humans have survived and prospered for thousands of years and have the intellectual and material resource to deal with climate change. However, we have to learn to cooperate on a global scale to an extent never before experienced in our history. I am optimistic we as a species can and will rise to the occasion. Thank you.
Thank you for your presentation. Let's now go to Module 2 of this program.